Hi students, Mrs. Moody again. Based on the conversation we had in class, you guys came up with a different strategy for finding the solution than I did in this video. So what I'm going to do is show you that your strategy is equivalent and just as good. We're going to come over here and solve the same rational expression, same rational inequality, but we're going to do it your way. So what you guys said was, the first step, let's make sure we don't divide by 0. So we set the denominator equal to 0. That's the same step as I did it before. Also, we need to make sure it is not that, right? Make sure we do not divide by 0. So we found our first critical point the same way, and that was what we talked about in class. The second thing you said to do was change this to an equals sign and solve that. So let's try that and see if we get the same answer. Equals 3. So now I'm going to multiply both sides by x plus 5. And we're going to solve this the same way we solve every polynomial equation that we've done so far. Now we're going to subtract 3x and subtract 15. Subtract 3x and subtract 15. And we have x squared minus 4x minus, oh, this is starting to look familiar. And we were left with 0 after we took all of this over to the other side. Check this out, because this is the same as what we did down here to change our numerator. It ended up that moving the 3 over and all that turned this new expression into our numerator, and what we did then was set our numerator equal to 0, and that's what we have here. The same thing. This is our numerator, but it is actually the same thing as the whole inequality changed to an equal sign. And now we find where it's 0, we factor that. It was x minus 7 times x plus 3. And now we have that x could equal 7 to make this 0, or x could equal -3 to make this one 0, and either one of those will make the whole expression 0. So these are our other critical points. We have found the same 3 critical points using your method of replacing with an equal sign, and I love it. So rather than all of the we're still going to have to check points and everything and look at the graph. But you guys also suggested maybe we should look at the graph to find out where we meet. See, this is an x. That should be an x, not a check. That does not satisfy the less than or equal to, right? So this one does, that one doesn't, this one does. And we went from all the steps here that I wrote out so wordily to you guys' answer that you came up with in class, and I love class discussions for this reason. Set the denominator equal to 0 and solve, looking for holes or critical points. Change the inequality to an equality and solve, finding those other critical points that are the same as the intersections of left and right, whatever's on the left of the inequality and whatever's on the right of the inequality. And then either you test the points or you look at the graph to determine which one makes the original inequality true, and state your answer in interval notation. Awesome. Well done, guys. See you next time.